I'm going to go ahead and just use a graph to answer this inequality question. I want to know when this rational function is less than or equal to 2. Now, normally we compare to 0 to see when we're above or below the x-axis, but actually this time I just want to rely solely on my graph. So I've gone ahead and entered in the two sides of my inequality into my graphing calculator. Note, if you don't have the newer calculators that do the fractions like this, make sure you have a double set of parentheses around that numerator. But let's go ahead and hit graph, and I'm just in my standard window to see what happens. So here is here's the left-hand side of the inequality, the hyperbola in blue, and here in red is the line where the graph is at 2. And so the question was, when is my blue graph, when is the hyperbola less than or underneath that y equals 2 line? Well, I can see that this part of the graph is no good because all of that's above the x-axis. So I want to describe the interval down here. Well, what I'll need to know is still where the vertical asymptote is. So as we always do with rational functions, the vertical asymptote is whatever would make the bottom equal to 0. In this case, that's just 0. So I have this dashed line. I can sort of think of this as my number line, although really I'm just talking about the graph this time. But I have this vertical asymptote at x equals 0. So I know that anywhere to the right of that is where my graph is underneath. So to start my solution, I've got a parentheses because I can never be equal to 0 because that would be touching a vertical asymptote and I can't do that. So a parentheses and a 0. And then I want to know how far out this graph goes where it's going to be less than 2. Well, I guess I could try to find where the blue curve intersects that red horizontal line because as soon as it intersects, it would cross over and be above. However, this time what I'm noticing is that 2 is actually the horizontal asymptote for this graph. Because I have equal degrees, I would go ahead and divide leading coefficients, and I would see that my horizontal asymptote is just 2. So this blue curve will never ever touch that red line, meaning as far out as I want to go, I'm always going to be slightly below it. So that's why I'm going from 0 to infinity to describe the interval where this graph is underneath that line where y is 2. I could double check this by looking at the table as well. If I make x really, really big, like if I keep scrolling down in my table, I can see that no matter what, the y value, the blue curve, is always less than 2. It's getting closer and closer to 2, but it will never, ever intersect. So the interval where this graph is less than or equal to 2 would be between 0 and infinity.